Hello everyone. So today we'll be solving this LeetCode medium problem, maximal score after applying k operations. So the problem states that we are given an integer array nums and an integer k, and now initially our score is 0. Now in one operation, what you can do is choose any index of the array nums and then increase our score by the value present at that element, and then replace that element with ceil of nums of I by 3. And we need to apply, we can apply at most k operations, means exactly k operations, and we need to return the maximal possible score that we can get. And here, like, ceil function, I hope you are aware of. So ceil is basically like, if we have 4 by 3, so now my integer division will give 1, but here ceil of 4 by 3 would be 2. So this is what ceil means here. So let's try to generate the output for given input. So for example, if we have the nums array as this, so what we can do is, in each step our score will increase by nums of I. So since we want to maximize this score, what will be the most optimal way will be to, like, choose this I such that this nums of I is maximum only, right? So that our score increases by the maximum factor. So here our means all the values are same, so if we choose any element, will means score will increase by 10 only. And let's suppose the new array becomes like 10 by 3, so 10 by 3 will be 4, ceil of 10 by 3 will be 4. So new array becomes 4, 10, 10, 10 and 10, and now we have applied one operation, so k becomes 4. Now since choosing this element is not good because score will increase by 4 only, so we'll again choose the maximum element of the remain new nums. So here the maximum element is again 10, so we'll choose, suppose, this element. So new array will become 4, 4, 10, 10, 10. After applying the operation, score will become 10 plus 10 equals to 20, and k will become 3. Okay. Similarly, again we will replace this 10. So this will 10 will become 4. Now operations will become 3. Operation will become 2. Then we can make this as well as 4 and make this also 4. So overall, like, 5 times we can use. So finally, like, score will become 50 and k will become 0. So suppose if we had k equals to 6, then again we can apply, like, new means one new operation on any of the elements of it. So 4 by 3 would be 2, so we'll get a score equals to 52 if k was 6. Let's try to try run for the next input as well. So we have the nums as 1, 10, 3, 3, 3. Let's sort it so that we are able to get the maximum element at each step. Now k equals to 3. So what we'll do, we'll pick the maximum element so that the score increases by a max value. So score is initially 0. Now we'll pick this, so score will increase by 10, and this value will be 10 by 3 equals to 4. Now again this new nums is sorted only. So again we'll apply the second operation on this number only. Now 4 by 3 will be 2. So score here will increase by 4, and the new modified array would be, we'll make this 4 by 3, so it becomes 2. So the new sorted array will be 1, 2, 3, 3 and 3. Now again we apply the same operation, apply the operation on the maximum element. So when we apply the maximum element, the score increases by 3, and this new array will become 1, 2, 3 by 2 will be 2 only, 2, 3, 3. Okay, this is a new array, but since k has become 0, so hence the overall score we get is 17, which is the maximum possible here. So what do we need at each step? At each step we need to means get the, so at each step after each operation we need the maximum element of the modified array. We need the maximum element of nums. If we get, means if we are able to find this maximum element after each operation, then our score will increase by maximum, this maxi, and the new element that will be pushed, means replaced with, will be maxi by 3. Alright, and then we will modify the nums and again apply the next operation till k is greater than 0. Now the constraints are like k can go up to 25. So this gives us an idea like we can apply each operation till means k times. Okay, so complexity can be of the order of big of k, or if for since we need to like maybe sort the array to get the maximum, so maybe n log n is also allowed. Okay, now how do we like get the maximum element after each operation? So one data structure that you may recall to like which will help us to get the maximum element after each operation is we can simply use a priority queue or multiset. Both will be fine. Why? Because here the top element and here the means last element would simply like give us the maximum element, right? Max element. And we can simply like once we have used this maxi, we can remove maxi and insert like we can insert maxi by 3. So we can easily like update the priority queue or the multiset by removing this maxi and then inserting this maxi by 3 in like log n complexity and hence we'll be easily able to get the max element at each step and we'll apply the operation till while k is greater than 0. We'll keep applying this operation like score plus equals to maxi and then remove maxi and then insert maxi by 3, seal of maxi by 3. And initially we'll push all the elements of the nums array to the priority queue or the set. Or also like you must be aware of this. If you want to calculate the seal of any means fraction, it is simply a plus b minus 1 by b. Okay, so now we can simply integer divide this. So here since b is 2, so it will be maxi plus 3 minus 1 divided by 3, which is maxi plus 2 by 3. Okay, so at each step we'll be calculating this fraction and simply pushing it in our priority queue set and removing the maxi at each step. And we'll do this also like since what if like after applying some operations the nums becomes like this. So we know that score will not increase here. So instead of like applying till suppose k was 25, okay, and the elements were like 1, 0, 0, 0 and so on. So we know like score will only increase for this array and after this 1 by 3 would again become 1. Okay, so this will never be the case where all the elements will become 0 because we are doing seal division only. Okay, so this will never be the case like we'll apply k operations effectively only because we will not be wasting any operations. So I hope like you may like think like we use like if like this maxi by 3 is greater than 0 then only push, but this will always be greater than 0 because for 1 by 3 the result will be 1 only. Okay, so we can just simply apply the operation till k greater than 0 and calculate this result. So this was a like a pretty simple problem. We just needed to be aware of priority queue and we'll be able to code this up. So let's see the code of the problem as well. So we are simply creating this priority queue. Then we push all the elements in the queue. Now we do not need this because priority queue will never become empty because maxi by 3, seal of maxi by 3 will always be greater than 0. Okay, so if you think like 0, 0, 0, so it will never be the case. Now we find out the top element of the priority queue. We increase our score by the top element and the new element will be element plus 2 by 3, that is a by b is a plus b minus 1 by b. Okay, so we'll push the and this since this value will always be greater than 0, so we do not need this as well. So now we'll simply do this and we'll finally return the score. And hence the overall complexity of this code would be since the maximum size of priority queue will be till n, so the complexity would be of the order of n log n. So I hope like the code is clear. Let's try to submit it as well and see how well it performs with the modified version. So we do not need this check of negation pk minus 20, and we also do not need this check because it will always be greater than 1. Now let's run it and submit it as well. And as we can see, like it runs in 87 ms, which is fairly good because the complexity is of the order of n log n only. So I hope like you get the logic of you already knew about how you can get the max element in log n complexity, and if you didn't, like we have this parity queue, or we can also use multiset, and then this problem can be solved easily. So I hope like all your doubts are cleared, and if you have any doubts remaining, feel free to comment down and I will be happy to respond. Thank you for watching.